This is a video for after the homework quiz, and the main objective of the video is to define biconditional statements and be able to use them. So you may want to pause this right here so you can copy this down in your notes. Basically what a biconditional statement is, the word bi means two, so two conditions. So we have the original conditional statement and the true converse. So true conditional, true converse, they're joined using if and only if. And so basically you can read it both directions. Sometimes the symbol is a double arrow. This is the abbreviation for if and only if. And so the way we usually like to look at these problems is to write them out and then write the converse and see if both the statement and the converse are true. So if you look here, it is a bird if and only if it has a beak. So one way to break this up is to take the if and only if out and say if it is a bird, then it has a beak. That would be the conditional. The converse would be if it has a beak, then it is a bird. And we're using it here, which is a little dangerous, but you might say animal or whatever. That's fine. We know what we're talking about. So what we will do later on is then we'll decide if it's really true or not. So if you say a statement and you can flip it around, is it really true? Again, second one here. It's the weekend if and only if it is Saturday. So the original conditional would be if today is the weekend, then it is Saturday. The converse of that would be if today is Saturday, then it is the weekend. Again, this one we'll talk about how to say whether they're true or false or not later on. This one definitely one of the things is true, conditional or the converse, but not both. So if you can prove one of the condition or the converse false, then the biconditional is not really a true biconditional statement. Okay, so it says write a biconditional statement which would represent each statement below and its converse. So if you think about the converse as kind of being the flip here, think about if you flip it, what gets moved around? Well, if you look at your if then, so if x equals 4, then 3x plus 8 equals 20. So can we take and divide our sentence here? So x equals 4 if and only if 3x plus 8 equals 20. Okay, so this is our if and only if symbol. You could also write if and only if. I like the arrows. I think they make it. So the converse there would be 3x plus 8 equals 20 if and only if x equals 4. Basically it's saying if you solve this, you get x equals 4. If you have x equals 4, then you have this equation. If an angle is straight, then it measures 180 degrees. So straight angle, if and only if the measure is 180. Again, I'm kind of abbreviating the words there. putting it into a biconditional statement. Two segments are congruent, then they are the same length. So congruent segments, if and only if same length. And you could put this into words. If two segments are congruent, then they have the same length. If and only if they have the same length. You can put it into a longer sentence. Two segments are congruent if and only if they have the same length. That's kind of a longer sentence form. It just depends on what you're trying to answer. Okay, now it says decide whether the biconditional is true or false. If false, which part of the biconditional is false? Provide a counterexample. Almost always you have to provide a counterexample and to show what part is false here. So I'm going to look at this and I'm going to think about what the biconditional is first. So the angle is obtuse if and only if it measures 133. I'm going to just abbreviate so I can think about this a little bit. So the angle is obtuse if it measures 133. Well, that statement is true. If the angle measures 133, then it's obtuse. The question is the angle obtuse if and only if it measures 133 by itself, or is there an example where it would be false? Like I would say that the converse of this is true, but obtuse does not imply 130 degree. And the counterexample would be 135, because there's not implied that our angle is 133. So if you flip it around, like the converse is true, if an angle is 133, then it's obtuse, but if it's obtuse, it doesn't mean it's 133. So when we did the initial notes, that's kind of how, if you get stuck, that's kind of how you break it out. You can write it as two different statements, or just think about it that way. A statement is a conjecture if and only if it is an unproven statement based on observations. So I'm going to write it out this way. If a conjecture, I'm going to abbreviate some stuff. If a statement is a conjecture, then it is an unproven statement based on observations. So I'm writing out the conditional, that the original order conditional there. If I flip that around, if a statement is an unproven statement based on observations, then it is a conjecture. I would say that is true. That kind of defines the conjecture, and the conjecture is defined by that. There may be some other words you could think of. It's a fish if and only if it lives in the water. So if it's a fish, then it lives in water. So I'm going to abbreviate this one. If it lives in water, though, then it is a fish. That would be false, because there are lots of animals that live in, lots of creatures that live in the water that are not fish. So when you're doing this assignment, make sure that you are careful with the directions, okay? So if you ever get stuck, you can always go back to writing everything out. I don't think you need to do that on every single one. So like these, you practice write the converse. So you already have the conditional, you're going to write the converse, and then you're going to write it as a biconditional. So you're going to have two things. You're going to have the converse, biconditional, and then is it true? And if it's not, give a counterexample. For the biconditional, if you want to abbreviate a little bit, you can, since you have the whole Converse, and Conditional here. So we just have several of these. Some of them have to do with math, some of them have to do with miscellaneous stuff, and then the very last thing is from your book. And if you want to put them down the side of the paper, put it on another piece of paper, you need to find your PDF book. If you haven't already downloaded it, it's on Canvas. It's also in the staff student shared folder under math textbooks or under Mr. Kirkton under the assignments, and drag it onto your desktop. We're going to start using your book a little bit more as well. We will go through these together when everybody's done on the quiz.